Hello, this is Geometry Lesson 8. In this, I will discuss quadrilateral basic concept. Now, first thing is, what is a quadrilateral? This is an enclosed figure with four sides. As you can see that I have drawn in figure. This is quadrilateral. There are four sides. First thing is that sum of all the angles in a quadrilateral is 360 degree. This is always true. Sum of all four angles is 360 degree. How? You can draw this a line between them, B and D. You can join B and D. This is angle 1. This is angle 2, this is angle 3, this is 4, this is 5, this is 6. You can say that 1 plus 2 plus 3 is 180. We know that sum of all the angles in a triangle is 180 degree. Same way you can prove that 4 plus 5 plus 6 is also 180 degree. Adding all this thing, you will get angle A plus angle B plus angle C plus angle D. This will be equals to 360 degree. 180 plus 180, 360 degree. Because 2 plus 4 will make angle D, 3 plus 5 will make angle B. Second thing is that how to find the area of this quadrilateral. Now in this such cases you need perpendicular lengths. Let's say this is a perpendicular length. This is H1. This is, let's say, H2. If you know the length of perpendicular, then only you can calculate the area of the quadrilateral. Now can I say area of this quadrilateral? Area of quadrilateral ABCD would be how much? Can I say that this will be area of triangle ABD plus area of triangle BCD. Now area of triangle ABCD is half into base into height, half into BD into H1, and area of BCD would be half into BD into H2. So if you know the length of BD as well as H1, H2, you can always calculate the area of the quadrilateral. Simply what you have to do, you have to make one diagonal, then you need two perpendiculars in order to calculate the area of the quadrilateral. Let's discuss some of the very important types of quadrilateral. First of them is a parallelogram. The basic definition you must have studied in class 8th or 9th is that a quadrilateral in which opposite sides are equal and parallel to each other, that is called as a parallelogram. The basic definition I hope everybody knows. This AB is equals to CD and AB is parallel to CD. AB is parallel to CD, also AB is equals to CD. Same way AD is equals to BC and AD is parallel to BC. Now what about adjacent sides? In this parallelogram I am taking AB is not equals to AD, as well as I am taking that angle A is not equals to angle D. Adjacent angles are also not equal. The parallelogram I am taking, it may or may not be equal, depends on type of parallelogram, but in this parallelogram that I am taking, the adjacent sides are not equal, AB and AD. Adjacent angles are also not equal. Now let's discuss the properties of parallelogram. You must have crammed this property in your class 8th and 9th. Now you don't need to cram, you only have to understand the things and no need to cram. First property says that if you take a diagonal, this diagonal will divide the parallelogram into two triangles of equal area, or you can say that the two triangles will be congruent. Can I say that triangle 1, this is triangle 1 and this is triangle 2. Can I say that triangle 1 is congruent to triangle 2? Triangle 1 is congruent to triangle 2 by SSS. All three sides of triangle 1 is equals to corresponding three sides of triangle 2. You can see that triangle 1 sides are AD, triangle 2 side is BC. AD and BC are equal. Same way AB and CD are equal and AC is the common side. So triangle 1 is congruent to triangle 2 by SSS congruency. It means that the diagonals will divide the parallelogram into two triangles of equal area. The area of these two triangles will be equal. Same way you can draw the other diagonal, and that means I have drawn the two diagonals. Second property says that opposites angle are equal in parallelogram. Opposites angle, it means that angle A is equals to angle C. How we can easily prove that? Now can I say that if this angle is 1, this angle is 1, this angle is also 1, because two parallel lines and AC is a transversal. AB and CD are two parallel lines and AC is a transversal. So can I say that these two are alternate interior angles? Same way, this is angle 2, this is also angle 2. Again alternate interior angles. Now you can see that BC and AD, in this time AD and BC are the parallel lines, AD and BC, and your, can I say that AC is a transversal. So these two lines, two angles will be equal, angle 2 and 2 alternate interior angles. Now you can see that angle A is equals to angle C. Angle A is 1 plus 2, angle C is also 1 plus 2. So opposite angles are equal in a parallelogram. This is second property. Third property is that diagonal bisect each other. Diagonals bisect. It means that this point is O. So this length OA will be X. OC will also be X. It means that your diagonal is bisected into two parts, same parts, X and X. If this length is Y unit and this length is Y unit. I am assuming that both diagonals are of different length. In this parallelogram, I am taking that AC is not equals to BD. It may or may not equal. It depends on type of parallelogram. But in this parallelogram that I have made, AC is not equals to BD. We can easily prove that the diagonals bisect each other. Now this is angle 2. Can I say this angle is 3? If I take this angle is 3, this angle will also be equals to 3. Again alternate interior angles. This angle is 4, this complete angle, this is angle is 4. 4 and 4 are equal because they are vertically opposite angle. Now can I say that triangle DOC is congruent to triangle BOA, because angle series must be same. DOC, when I say that, which angle are there? 3, 4 and 1. BOA, again angle series is 3, 4 and 1. So by which congruency these two triangles are congruent? Can I say that they are congruent by ASA, angle side angle. Now you can see that angle 1 and 3 are equal both in both the triangles, and there is an included side AB, and that other triangle there is included side CD. They are also equal. So ASA, two angles are equal, 1 and 3 in both the triangles, as well as there is an included side. You can say that AB and CD, they are also equal. So these two triangles are congruent, and we know that when the triangles are congruent, the all corresponding sides as well as all corresponding angles are equal. Now how to determine which side, corresponding side would be what? Now can I say that in this you have to check the angle. Can I say that AO is the side of triangle BOA. This triangle, the side, one of the side is AO. What will be the corresponding side to this? Very easy to check. When I say length AO include angle 1 and 4. On the side AO, the angle 1 and 4 are there. Angle 1 is there, angle 4 is there. Between angle 1 and 4, the side AO is there. The corresponding side on the other triangle will also be on the same angles 1 and 4. Angle 1 and 4, between angle 1 and 4, which side is there? On DOC, between 1 and 4. You can see that between 1 and 4, the OC is there. OC. This is the side of other triangle 1 and 4. So can I say that AO corresponding side would be OC. Same way, BO corresponding side would be DO. So can I say that AO is equals to OC, BO is equals to DO. These are the, you can say that Y and Y they are equal, and X and X they are equal. So I have proved that AO is equals to OC means the X and X they are equal. Same way Y and Y they are also equal. So very important property is that diagonals bisect each other in a parallelogram. Next is how to find the area of the quadrilateral or parallelogram in this case. Now area, we know that is simply the base into height. So we can draw the height H. Let's say the height of the parallelogram is H. So can I say that area of quadrilateral, or you can say that area of parallelogram in this our case ABCD. What will the area of parallelogram ABCD? Can I say you have to calculate the area of triangle ABD plus area of triangle ACD. Both will be of same area, because we know that the diagonal divides the parallelogram into two triangles of equal area. Both the triangles are congruent. So ABD and ACD, both will have same area. Both will have same area. Now what is the area of triangle ABD? We know that half into height into AB, and the same will be there for this triangle. Otherwise you can also calculate that area of triangle ACD is half into height will be same, and CD is the base of the triangle ACD. Height will be same because between two parallel lines height always remains the same. If the two parallel lines are there, the height is always one height, that is h, and that will be the height of all for all the triangles. So in this case height for triangle ABD as well as ACD will remain same. So can I say that this is twice of half into height into AB. So half to height cancel, height into base will be the area of parallelogram. That is, you can say that generalize, you can do that. This is height into base. So base, you must know that base of the parallelogram and the height of the parallelogram. So you can always calculate the area of the parallelogram. Next is rectangle. Now rectangle is a parallelogram with equal adjacent angles. The first property is that rectangle is a parallelogram. It is formed from the parallelogram. So every rectangle every time is a parallelogram. Vice versa is not true. Every rectangle is a parallelogram. Every parallelogram is not a rectangle. So now in parallelogram, this is the left side, this parallelogram, I can say that angle A is not equals to angle D. But angle A plus D is 180 degree. This is true for every parallelogram because they are the interior angle on the same side of transversal. Interior angles on the same sides of transversal, their sum is always 180 degree, as I discussed in lines and angles. So A plus D is always 180 degree, but A is not equals to D. So this figure on the left hand side is a parallelogram, but this is not a rectangle. On the figure on the right hand side, this is also a parallelogram. Opposite sides are equal and parallel. But in this case, angle R is equals to angle P. We know that P plus R would be, angle P plus angle R will always be 180 degree. Because in a parallelogram, the sum of adjacent angle is always 180 degree. But in this case, I am saying that a parallelogram with equal adjacent angle. So if angle P will become angle R, so there will be a each of 90 degree, then only their sum will be 180 degree. So can I say that if in a parallelogram adjacent angles becomes equal, that parallelogram will become a rectangle. This angle will 90 degree, this angle will 90 degree. Same way this angle will 90 degree and this angle will 90 degree. So this will become a rectangle, and this will be a parallelogram also. So this is a rectangle as well as this is a parallelogram. Whereas the figure on the left hand side, this is only a parallelogram, this is not a rectangle. As I mentioned below, this is not a rectangle, only a parallelogram. So rectangle is a parallelogram with equal adjacent angle. All other properties are same. That diagonals bisect each other, everything will be true because rectangle will show every property of parallelogram. Opposite angles are equal, diagonals bisect each other. Additional thing in rectangle with only as compared to the parallelogram is that in this case diagonals are of different length. In this case AC is not equals to BD, but in a rectangle the diagonals are of equal length. QR will be equals to PS, PS will be equals to QR. That is an additional thing, is that the diagonals will be of equal length in rectangle. Whereas in the figure on the left hand side, this is parallelogram, in this diagonals are not of equal length. That was all about geometry lesson 8 quadrilateral basic concepts. In this I discussed what is the quadrilateral, parallelogram and rectangle. I will continue with more on the quadrilateral basics in the next lesson. Thank you.